I'm looking, this is Richard Collins, and I'm looking at the record for Bad Homburg, their SG044. The gravimeter is just called BH044. And from your paper, there was an 11th March 2011 earthquake that you were looking at. So I thought I would see what the record looked like in there. I can't be absolutely certain because I'm just taking a few minutes to check on your timings, but I thought you might be interested in what was going on at a quiet station. This background signal is what I call the sun-moon signal, and I can model that at 99.99% with a simple Newtonian tidal gravity from the sun and the moon. That's what I use to calibrate the stations. So once I do that, you can subtract this off and just look at this residual of this activity. But here, I don't want to go in and do a lot of programming right now, so here is the day. This is just one day, and I noticed that this tail doesn't clean up. Okay, this is the normal smooth signal at the station, and so this is abnormal, and it almost certainly relates to this event. It's so large, and so I expanded that scale for 2 days. And to me, I'd have to look at this a little bit more closely, but I think you're seeing residual even a couple of days afterwards. These are quite sensitive. I don't have this on an absolute scale. These are in volts here. These are actual signal outputs from the gravimeter, the vertical component. It only has vertical, and they're in volts. When I do the calibration, I convert that into nanometers per second squared, and the range on here is plus or minus 1,000 nanometers per second squared. So roughly, it depends. I have to check the station. I'll have to do some more reading to find out exactly what I was going to try to do. We're at point 361 in here. Let me see if I can get down to there real quick. Okay, and that's, wait a second, that's going to be relative to here. So alright, so 2011 in these are minutes and seconds here. Let's see, this is the signal. Let's go back. I'm just going to pick up a little bit of this and just see if I can pick up the early parts of this. So let's throw a okay, that is I must have gone, oh, because yes, 2011. Yes, it was relative to the beginning of the day. I'm sorry. Okay, let me go down to the 11th. Okay, and let's just do. And it was the 360 seconds into 360 minutes. Alright, I apologize. It's been long days. Okay. let's pick up some of this here. This is the signal, and let's see if I can get in here. Okay, that looks like I'm finally finding the beginning of the signal here. This is the normal signal was, staying anyway. This is a pretty good sized spike here for this. Now, can you unravel it? If you subtract the calibrated sun-moon signal, the residual is pretty much all the event. That's a very quiet place, and I would think that most of the acceleration and higher time derivative events in there are going to be all earthquake related. Let's see if I can try to help you piece this together. All I wanted to show you, actually, okay, and where did this begin? That was what I was trying to figure out. Okay, so let's see. Sorry, in here, this event series 1.21.3645. So the very first thing is occurring at the 21st point in here. This is so crude. Okay. Mark this one 20. Okay, let's just mark that, and that is somewhere around there. So I don't know the timing in UTC. I'll have to read your paper again and see when exactly this occurred. I don't know if Bad Homburg or any of the other stations are keeping their 1 second data. This is 1 minute summary data that gets posted on the web, and I've used it for these general calibrations, since I can take a month of the signal from here like this, clean this up, remove these, fit it once, remove these types of events, run it again, get it cleaner, and then remove still more, and get basically a good solid calibration on the background quiet signal there. Then the residual is useful for unraveling other things. So you can effectively flatten this out and only look at the earthquake portion of this. There's a lot of structure in here, and if you think of this as an instrument pointing at the earthquake through the earth, is this the seismic signal itself arriving? Is that what happened, or was there a little tiny blip in here that signaled ahead of time? So that's what you guys were trying to do. I don't know if you looked. I mean, I'm just this is general interest on my part. I wondered, did you look at all the superconducting gravimeter records for those events, because they're quite a bit more sensitive, and they have very good long-term stability, so they're easy to calibrate and all. Now look here, there's this thing that could be just a local event, but it's considerably earlier. I don't know. I'll have to do some numbers and read more carefully and find out exactly where this was, when it was, and so forth. But I thought I'd show you. Here. Okay, let's look. All right, it's 2011. Let's go back. Level 1. Oh, okay, go up. Up. I have to go back. This is their FTP directory. One more. I don't know. We'll see. These are newer. Yes, okay, 2011. And here, oh, that's auxiliary. All right, that's not, I don't think that's going to get us what we need. I'm going to just keep going back up there. I'm just curious. I'm going to look at one more thing. I hate to make this so long. Indonesia. Let's see what happened there. And we have the 2003 event here. Okay. I need an index to this whole thing. I keep meaning to do that. Canberra? Let's try Brussels. There. Okay, I'm sorry. I thought I could just grab another one for you and see. There's a few records. You know, like I say, you have to do some digging because the 1 second data, some of the stations are beginning to run at 10 hertz, which allows you to chop the signal down even finer. But mostly there's this minute data, and it looks like those events are like day-long events from the point of view of a superconducting gravimeter. So anyway, I'll stop